told that girl to get off that stupid game. All she does is play that stupid game all the time.
Come on. Oh, come on.
Dakota.
Win it. What? Get out of my room.
Why are you on this game again?
I'm trying to get to the next level, Dad. Get
I
out.
don't care. Look at your grades. You're never going to get nowhere in life with these stupid grades.
My teachers are just dumb. Whatever.
Maybe you're the stupid one if you're failing all these classes.
Whatever. All my teacher wants to do is talk about dissecting cats and muscles.
Well, I don't care. There's actually a special coming on about muscles, which you should really watch.
Do I need to watch that dumb
educational
video?
Yes.
I'm not watching it.
Yes, you are.
No, I'm
Get
not.
off this game and
No.
Watch the movie.
Fine then.
Hello, in this episode we are going to learn about muscles and everything that they are made up of. This is a muscle. It is connected to a bone by tendon and other kinds of ligaments. Each muscle is made up of bundles of fascicles which are covered in perimysium. There are many of them to make up a muscle. Each fascicle is made up of muscle fibers. The muscle fibers are covered in a thin covering of endomysium. On top of each muscle fiber, there are transverse tubules, which aid in sending electrical pulses deeper into the cell, and a thin covering of sarcoplasmic reticulum, which stores calcium. Each muscle fiber is made up of myofilaments. There are two kinds of myofilaments: thin filaments, which are actin, troponin, and tropomyosin, and thick filaments, which are myosin. In between two Z lines are sarcomere. Sarcomeres aid in the contracting of muscles. And that is it for today.
Good afternoon. I'm Dr. Joe, and I want to talk about the binding sites of thick and thin filaments before and after binding to calcium. Within a contractile bundle of a muscle cell called a myofibrin, the calcium interacts with myofilaments to trigger a contraction in each contraction unit of sarcomere. Synactin and thick myosin filaments are juxtaposed but can't interact with the absence of calcium. This is because the myosin binding sites of the actin filaments, which are red, are covered with the protein called tropomyosin, which are blue. A calcium-sensitive complex called troponin, which are these, is attached to the ends of the of each tropomyosin molecule. When calcium floods, each troponin binds to its moving tropomyosin off the myosin binding sites, opening the myosin binding sites of actin filaments, allowing the myosin motors to crawl along the actin sites, resulting in a contraction of a muscle fibrin. Calcium is the return of the endoplasmic reticulum by the action of a calcium pump. Without calcium, myosin releases actin and the filaments slide back to the original position, which is called relaxation.
Oh, you're such a cute little baby. You're such a cute.
Hello, I'm Dr. St. Patrick, and today we'll be learning about the anatomy of the neuromuscular junction and the different parts involved. The neuromuscular junction can also be known as the synapse. This area right here is called the motor end plate. It is the flattened end of a motor neuron that transmits neural impulses to a muscle. Synaptic vesicle chemically assists the transfer of an impulse. The neurotransmitter is also called acetylcholine. The chemicals involved in the neuromuscular junction are calcium, sodium, and potassium. The neurotransmitted gated channels include the voltage gated calcium channel and the voltage gated sodium channel. The synaptic knob is this area all around here where an axon ends and it stimulates other nerves or a target organ where physical response happens. Thanks for tuning in and stay tuned for the next episode.
And somewhere in my heart, I still love you.
Hello, I am Dr. Tupac, and today I will be showing you how the motor unit works. This here is the axon terminal. This is a Schwann cell, the nerve, calcium ions, exocytotic vesicle, gated channels, acetylcholine vesicles, mitochondria. These are the proteins. This here is the synaptic cleft, sodium ions, potassium, and the sarcolemma. These are the acetylcholine receptors. What first happens is the nerve has an impulse to the synaptic end bulb. The gated channels are opened. The calcium ion comes through and reaches the exocytotic vesicle. It sends a nerve to the acetylcholine vesicles and they release the acetylcholine into the synaptic cleft. The synaptic cleft has the acetylcholine inside and the acetylcholine receptors become full. The sodium ions come through and the potassium is released. Once the potassium is released, it goes to the sarcolemma and makes an action potential. The action potential makes the sarcolemma become depolarized. And that will be all for today. Have a great day. My mom just canceled my sister's World of Warcraft account and she's like totally freaking out. Oh my god, you're gonna see this. Get out of my room! Did you see that? Did you see that? Hi, and welcome to the last session of this program. I'm Dr. Calico, and I'm about to show you a 3D model that I built in a 3D program called Maya. The model that you're about to view is going to be a 3D model of a muscle contraction inside a filament. So, shall we get started? As we can see, myofibrils are on top. Calcium reacts with tropomyosin and tropophin to create a spinning reaction. This reaction causes actin to create myosin binding sites. The myosin binding sites makes the myosin head react and make a myosin crossbridge. The myosin crossbridge is what's going to make our muscle contraction and our power stroke. In order for the power stroke to happen, we must have ATP, energy. ATP reacts with myosin crossbridge to make ADP and inorganic phosphate. The inorganic phosphate and ADP reacts with the myosin crossbridge to prepare it to bind with actin to make a power stroke. Once this is done, the cycle begins all over again.
And this concludes our program. Thank you for watching and have a nice day.
This has been a No More Chains production.